So I'm going to cover updates on new technology for sacral neuromodulation today. We're going to start with the timeline. A lot has happened in just the last 5 years, really. And then we're going to talk about some device updates, as well as the new devices that are coming to market. And then we're also going to talk about some programming innovations, which is actually one of my areas of expertise, because as we develop these new devices, we also need to make sure that they're going to last the amount of time that we expect them to. I do not have any disclosures. So the timeline for neuromodulation, this has been around 25 years. 1997, InterStim was first launched for voiding dysfunction. And initially that was the cutting down to the sacrum, inserting the lead and putting permanent sutures into the fascia. In 2002, the timed lead was developed to secure that lead in place without the cut down. The first pudendal paper of placing the InterStim device on the pudendal nerve was published in 2005, and then the InterStim 2 was launched in 2007. There was papers on the dorsal genital nerve being published for urgency or sexual dysfunction starting back in 2008. And then in 2010 was when we started looking at more of the tibial devices. The Summit trial for PTNS versus sham was in 2010. 2011, the InterStim was approved for fecal incontinence. What started with voiding dysfunction then expanded out to fecal incontinence. Around this time, non-obstructive urinary retention also became one of the FDA-approved indications, at least in the US. And then just here recently, in the last few years, this has been an explosion of new technology in neuromodulation. In 2015, new competitors to Medtronic came out, the Axonic, Nuvectra, and Nuspera. We're going to talk about the Axonics and the Nuspera today. And then certainly there's been an explosion in the tibial nerve stimulation as well. And we're not going to go into detail about this today, but these are some of the names that you're going to be hearing more and more about. The whole idea is one of the things that holds the patients back from being able to commit to PTNS is that coming into the office and getting the stimulation in the office every week is hard to commit to, and we lose a lot of patients with that. So the newest devices are implants in the next to the tibial nerve, where patients can go and stimulate that tibial nerve at home. So some of the new ones you will hear about is Bioness, the BioWave, Blue Wind. It was recently approved in the US, but has yet to be used frequently at this point. StimGuard, Valencia, and Neurostim, all companies that are developing in that tibial nerve stimulation realm. In 2019, Axonics was approved for use in the US, and Medtronic quickly came out with a rechargeable version themselves a year later. So we'll talk about some of that. And then just here lately, 2022, the Axonics came out with devices that are both rechargeable and recharge free, and Medtronic has done the same. So now we've got two companies that are really head to head in their developments of this technology. So we're going to go through that in detail today. So despite this technology being here for 25 years plus, there's still only 350,000 implants that have been done since 1997. So there's still quite a way to go to make this as diffuse as really what is needed. There's still a small amount of people that go on to the third line therapy when really there's much more that probably need to go on to third line therapy. So device updates. We're going to start with the Axonics device. So this is the Axonics device. In comparison to the InterStim 2, the Axonics device is 60% smaller, is a much smaller volume as well, with only 5 cc's versus 14 cc's. It's lighter. Even though it's smaller, the telemetry, the ability to communicate with the technology is still very good, with 3 centimeters of depth and being able to communicate transcutaneously. And then this is when it first came out, the big wow factor was the 15-year battery life. where before InterStim 2 was thought to last 3 to 5 years before the battery needed replacement. So 15 years was a big deal. This rechargeable device, they accomplished this through using a ceramic window here at the tip with the recharging coils beneath the ceramic window, which allowed for a very fast recharge. So when this was the first of its kind, created a lot of wave and excitement when it was first developed. The Artisan study is the 2-year outcome study on the Axonics device. This was done at 19 U.S. centers, 129 patients. And interestingly, it was a non-staged procedure. So patients who qualified, it was all urgent continence patients. And if they qualified, they went right to the full implant without doing the typical first stage trial and the second stage as we typically do. And so even without those trials, there was still a very high response rate. Now, keep in mind, these are implanters who implant a lot of InterStim, so they're very talented in the implanters. But 90% response rate is really great, and that was maintained throughout the 2-year period. So looking at some of that data, their average urge incontinence episodes, the baseline was 5.6 episodes daily. And at 6 months and up to 2 years, they maintained that significant reduction in urge incontinence episodes, with averaging 1 urge incontinence episodes per day. So in the US, in order to have that device be approved by insurance, we have to reach a 50% improvement. So the 50% improvement was actually a small amount of this group. The majority of the group had a very significant improvement, with the largest majority of the group being 100% dry. So this was different from prior studies, but again, keep in mind these are very talented implanters who do a lot of implants, and they chose their patients well, I'm sure. They also showed that the device not only improved the urge incontinence episodes, but also improved other aspects of their life. As we all know, patients that have significant leakage, that affects different parts of their life, their sleep, their social aspect, and that they had improvements in all aspects of their life, not just the urge incontinence. These patients had significant satisfaction with this therapy, 94% satisfaction rate. And the charging experience, which we'll talk about, they got also good reviews, that patients felt like this was easy to do. The frequency and how long it takes to charge their device was not prohibitive of their life. So the Axonics was a great innovation for being a small device. It was rechargeable. Nowadays, it is MRI approved, both the full body 1.5 and the 3 Tesla MRI, which is important. A lot of our centers are moving to this 3 Tesla MRI. It's been approved in Europe, Canada, and Australia, and it was approved in the US in November 2019. The latest innovation is a recharge-free battery. So and that's slightly larger. I'll show you a picture than the rechargeable version, but will also last 10 years. And that's important for deciding which patient is best for which therapy, and we'll talk about that. So this is the current state of the Axonics technology for sacral neuromodulation. The rechargeable with the ceramic window is the R15, and this recharging interval is the least frequent in the industry right now. It's once a month for an hour or less, and they attribute that mostly to their ceramic window innovation there. It's a 15-year battery life. It is very light at 5 cc's, and again, it's MRI compatible. Both these devices are constant current, which is, at this point, all of the devices are constant current. The idea behind constant current is that the stimulation is constantly adjusted, so that if you have impedances building up, and impedance can be scar tissue between the nerve and the device, or impedances or fragmentation in the lead itself, that constant current can adjust for that constantly without having to change how much power is going into the device. So that's why that was incorporated into this newest technology, constant current, and that was new to market with Axonics. The F15 is the recharge free. So this allows patients to implant the device without having to recharge constantly. And this is on average 10 to 20 years is the estimation. And I tell my patients that 10 years would be what I anticipate for this device. And it is also very light at 10 cc's. The remote for the Axonics device is also different from the competitor Medtronic, and I'll show you that. They chose to go with a much simpler remote. This remote has 2 programs available on it, and really all the patient can do is change between those 2 programs and increase or decrease their amplitude. And this device does not require another communicator. This device communicates directly with their program without having to put anything over top of the skin to communicate with the device in the remote. So that's one of the advantages that some people like about this, is that it's a kind of key fob is what they call it, easy device to manipulate with no communicator or third piece of this needed. So that's one of the major differences between the 2 groups of Axonics and Medtronics, is the remote and then the ceramic window with the fast recharge. Medtronic, not to be left out of the race, also had several innovations around the same time period. And so in the last few years, they developed a more robust PNE lead. So the PNE, the basic nerve evaluation, is the test phase for the sacral neuromodulation device that's done typically in the office. And it can be done under x-ray in the office or with just landmarks, bony landmarks, and measuring the coccyx to place this temporary lead, attach it to a battery, and test that therapy out. So the PNE lead, they made it more robust and has this coil style to it with a single electrode at the tip. So the advantage of this is that once this lead is placed through your needle, the electrode at the tip is less likely to migrate with this design, because if the lead has any tension on it, it will actually start uncoiling, and we call it, it's like a slinky, where it will uncoil and the tension will be released by uncoiling the lead without actually moving the tip of the lead. So this is thought to have a much more reliable trial, because it's difficult to move this to move the tip of this lead unless you uncoil the entire thing. And when we pull these out in the office, you'll find that they're very long, much longer than you anticipate, because they have to uncoil to take everything out. So that's been one of the new innovations. Now Axonics also has a PNE lead, but it does not have the coil look to it. The Medtronic has also upgraded their patient controller. So it now looks like a Samsung phone, with most patients do have touch tone phones nowadays. So this looks very familiar for patients, and it has a lot of capabilities. So on their screen, they have the clinician app, which is what I would use to look through their controller, and then their therapy application, as well as their charging application. On their therapy application, they can turn their device on and off. They can adjust the stimulation up and down, and they can change programs. This programmer can hold up to 11 programs, but it holds 7 standardly. They can also check their MRI compatibility and put it in MRI mode. Much like putting your phone on airplane mode, this can go into MRI mode. And of course, check the battery life. So a lot of capabilities right here in the patient's hand. And then from the clinician app, which requires an additional passcode for me to get in to access their device, I can do all of those same things, but I can also check impedances and make sure there's no fractures or interruptions in the device. And I can enable and disable programs, add additional programs to their device capabilities, and view their usage logs. And then another nice addition with this Samsung phone is the ability to have Zoom as a Zoom app, so that you can communicate with your patients, or they can communicate with the device reps over Zoom in order to review how you use their therapy. And that has been a very nice addition, especially during COVID, to keep those patients from having to come into the office. Medtronic also, in the same timeline, developed a small rechargeable sacral neurostimulator. This also has a 15-year battery life and is also MRI safe, 1.5 and 3 Tesla. So both companies now have rechargeable and recharge-free IPGs, or batteries. This was approved in Europe in 2020 and in the US in June of 2020. So this is the difference in size, that InterStim 2 that we're all pretty familiar with, and then the Micro is a much smaller device. So now that we have these two options available, the question is, who gets which device? What kind of patient is going to want a recharge-free versus a rechargeable? So absolutely, we need to think about patient compliance with recharging. Now, these batteries are advanced such that if the patients forget to recharge, it's not that the battery can get so low that the devices no longer communicate. So that can happen with our older batteries, but does not happen with these new batteries with both Medtronic or Axonics. But still yet, you don't want the patients to forget about these devices and not charge them, and the device is no longer to be helping them. So patients that are either do not feel up to charging this device because they travel with their lifestyle, they don't feel like they have the technical knowledge to keep up with charging, or they just have that kind of forgetfulness, but now that these batteries are going to last 10 to 15 years, it's important to think about not just where they are at the moment that you see them, but where are they going to be in 10 years with this battery? Are they going to be able to keep up with the charging? The charging on the InterStim device is going to be every other week. So like I said, Axonics has the least frequent need for recharging. And of course, the dexterity of having to put the communicator over their battery and do the charging sequence with their dexterity is limited, that recharge-free version might be the right one for them. For a rechargeable, these patients are typically more technology savvy and compliant and a motivated patient. I certainly use this more often in patients that are thinner. There is a significant size difference and weight difference here. So these patients that are much thinner are typically have less pain or discomfort with the battery itself with the smaller micro rechargeable. And I've certainly used it in patients with a history of device infection or a history of pain. You do not have to make as big of an incision for this micro rechargeable battery placement. So certainly the side profile is much better for thinner patients. And so I think these three reasons are the top reasons that I'm using the micro rechargeable. And I, of course, leave it up to patient, but many patients, if they're normal BMI and they don't want another device to charge up in their life, will go for a recharge free, because the difference now between 10 and 15 years is not as big as it was when we were looking at 3 to 5 years versus 15 years. And Medtronic has also come up with the InterStim X, which came out in February of 22, and this has a 10-year battery life. So at this point, Medtronics and Axonics are on the same playing field with the duration that their batteries are expected to last. And it's more of the subtleties of how the two devices charge and how and what kind of programmer is that patient best matched to. And then there are some new devices. So the one I want to talk about in detail tonight is Nuspera. This is this was the first study, a feasibility study, was in 2019, and this is a lead-only IPG-free system. The implant is a 4-centimeter sacral lead with the receiver built in here, and it requires no tunneling, has no IPG, and the stimulation is driven by communication transcutaneously on the sacrum, and it's quite small. So I'm going to play a video here, and I'm just going to talk you through it because I don't think that you can hear the audio. So the size difference, it's much smaller, and it's just about the same size as that lead plus the tined leads. The placement is very similar to what we're all used to, using the finder needle to locate that S3 nerve root, and then a dilator sheet, and then that Nuspera device is placed through the dilator sheet into the S3 foramen and is left in place in the S3 foramen. The lead is placed adjacent to the S3 nerve, just as we are used to, and then this is the communicating device. It is placed transcutaneously over the device to give that constant stimulation. So it's like wearing a patch on the skin to give that communication to the device to have it function, instead of tunneling and placing an IPG. And this is relatively discreet, but does require wearing that device underneath your sacrum, underneath your underpants, I guess, above the sacrum. So this is starting. I'm hopefully going to be one of the implanters for this, and this is starting here in the next year. We're going to be doing the trial for this, and so more to come on the Nuspera and who is ideal for this therapy. All right, so now that we've talked about the different devices available, and we're talking about devices that are going to last 10 and 15 years, we also need the device itself and the lead to last that amount of time. In the original studies with Medtronic, about 18% of patients had some kind of adverse effect where they had a change in stimulation, ineffective therapy, painful stimulation that required a change. So one thing that is a necessary part of this is to make sure that we're also keeping up with how to program this device, ideally for each patient. So just to review, so we're all on the same page, there are 7 standard programs that come with the devices. And in the Medtronic version, all of those programs are at the patient's fingertips, and they can try them themselves. In the Axonics group, there's only 2 programs available on that key fob. So let's talk about these programs and what that means. So with the placement of the lead, that's going to be in the S3 nerve root, and the whole goal is to have that lead really follow the direction of the nerve, so that and that's optimal lead placement, so that all 4 electrodes are adjacent to that nerve, and you're getting that inferior lateral direction to the lead. The goal is to have each of them stimulate the nerve in less than 2 milliamps is a good placement. And that means that electrode is sufficiently close that it can get that nerve stimulation at a low amplitude. At those low amplitude is what's going to give that device longevity. If you're putting a lot of power into the device, the battery is expected to not last as long as we anticipated. So with Medtronic, they'll give you a lot of resources. Patients will need to keep track of their symptoms, try different programs, and be able to give feedback about what is the ideal program. The program is based on the cathode so the negative. The cathode is where the energy starts. Programs 1, 2, 3, and 4 each pick an electrode that is where the energy starts. Programs 5, 6, and 7 share 2 electrodes as that origin of the cathode. And that gives us our 7 standard programs, which is how going to stimulate that nerve. Now look what happens if we don't have optimal lead placement. If that lead is not following that nerve the way that we hope to, what happens is that only one of those electrodes are close enough to reach the nerve and give that stimulation at less than 2 milliamps. These other electrodes are having to put a lot of energy into the device to get that same stimulation, or may not be able to get that same response at all. And so that's why this lead placement is the most important factor in our technical placement of these leads, is making sure that all 4 leads are available for use. And when we aren't able to reach that threshold, that's when we often see patients not reaching that 50% efficacy, and we may need to not be able to place the device, may have to remove it, and may have to reprogram. There are, like I said, there are 11 programs available, so there are options outside of the 7, but reprogramming the device outside of those 7 programs has a low likelihood of success. So this is what most of us are familiar with. We know that the patients are going to try a program and figure out what works best for them. And we're going to have the patient increase the amplitude or the intensity of the strength of the stimulation. But there's also different areas that we can adjust this device. And these are the areas that are still being explored in this technology. So one area that I've been particularly interested in is the pulse width. This is the duration of each stimulation pulse. And then the rate or frequency or number of pulses per second are also 2 other parameters that we can adjust when it comes to the energy put into this device. So on our clinician programmer, we can change, of course, the programs, but so can the patients. What we as the clinicians can also change is the frequency and the pulse width. The standard frequency is 14 hertz. You can also do a low frequency stimulation or a high frequency stimulation. And these have been explored mostly by Peters and Dudding, and we'll go through those studies. The pulse width can also be changed. The standard pulse width is 210 milliseconds, and that pulse width can be shortened and it can be extended, with the highest being 450. And this is the research that I have done. So starting with the frequency, Peters et al. Looked at changing the frequency for overactive bladder patients. And they did a randomized crossover study with 12 patients and tried alternative frequencies of 5.2, the low frequency, or the high frequency of 25 hertz. For the most part, they did no more incontinent episodes at that low rate of stimulation, and most patients responded best to the 14 hertz. So when it came to overactive bladder, it did not seem to change the therapy significantly and worth going outside of the 14 hertz frequency. Interestingly, with fecal incontinence, that wasn't necessarily the case. The Dudding et al. Tried different parameters with frequency fecal incontinence for sacral neuromodulation. They tried low and high frequency and low and high pulse amplitudes. And the high frequency stimulation was preferred for more than half of the patients. And this is specifically in patients who were unsatisfied with their sacral neuromodulation therapy. So this study does open up a window of opportunity for patients that are unsatisfied with their sacral neuromodulation for fecal incontinence, that perhaps we should be exploring high frequency stimulation for those patients. So I am personally interested in the pulse width, and with this animation, I'm going to show you why I'm interested in the pulse width. So in this animation, whenever the nerve turns bright yellow, that's a nerve that's reached excitation. So the pulse width allows for certain nerves to be excited at a certain pulse width. When, sorry. So the standard pulse width, you're going to get a certain amount of nerves excited and stimulated. When you increase that pulse width, you actually have more opportunity for more of the nerve fibers to be recruited and excited. So you're going to recruit even the smaller, harder to excite nerve fibers with the expanded pulse width. Now, this phenomenon also exists with amplitude. By increasing the amplitude on the device and putting more power, you're going to recruit more nerve fibers. However, if you will probably note this with your patients, that amplitude is very limited by the patient's perception of that strength of their stimulation. That is not the case with pulse width. We can make vast changes in pulse width without the patients having a significant a change in how they feel that stimulation. So that's very different with pulse width versus amplitude. And recruiting more nerve fibers might give us more opportunities to program or fine tune this device. Now with the shorter pulse width, it is by using shorter pulse width, you're only going to excite the largest, most easily to excite nerves. So why am I interested in the shorter pulse width? And that is because many of the studies that animal studies have been done by Sue et al. Have shown that we can actually use a shorter pulse width and get the same motor response. So a shorter pulse width might actually give us a potential for battery saving. And that's one of the innovations that might be helpful, especially if we are looking at the end of life of a device and you're trying to stretch that end of life out longer. So this is one of the studies we did at Cleveland Clinic. We looked retrospectively at pulse width manipulation compared to just changing the program alone for patients that were unsatisfied with their sacral neuromodulation. And what we found is that we had higher improvement in efficacy for pulse width changes versus program changes alone, and better relief of painful stimulation. And this is particularly true of a shortened pulse width, helped eliminate painful stimulation in 50% of the group that this was their main complaint. So this opened our eyes to perhaps pulse width is a way for us to troubleshoot these devices that we hadn't previously used. And then this study is in press, will be published in Neuromodulation. It's a prospective randomized crossover assessment of the effect of pulse width variations in overactive bladder. And similar to the way Dr. Peters did their study, this was a crossover study where we trialed all versions of the pulse width, the shortened pulse width at 60, the longer pulse width at 420. And what we found was that there was no major difference in efficacy. So that means that all of these pulse width can be used for patients without expecting a major difference in the way the device works, or a major difference in the way the patients perceive that stimulation. And then we did have 37% of the group that preferred an alternative pulse width, whether that be a shortened pulse width or an even greater quarter of the group that preferred the longer pulse width. We also, and they had a significant response to their urinary frequency on these alternative pulse width. We also noted that the shortened pulse width did use less battery power, so we found that confirmed a lot of the animal studies that had been done. So future directions in programming, we do need more studies that are done to give us evidence-based protocols for troubleshooting when patients have unsatisfaction with therapy, whether that's painful stimulation or ineffective therapy. We'd also like to work more on matching specific parameter modifications to specific indications. For instance, non-obstructive urinary retention, would those patients do better with a higher pulse width? Would we, if we get more nerve fibers excited and engaged, perhaps they would do better. So there is more, there's more opportunity in this realm to specify the therapy for each patient. All right, so that's all I have for you. So I'd love to take some questions. This is a picture of Columbia, South Carolina. I'm sure not quite as beautiful as where you all are, but it's not so bad.